Welcome to part 3 of integration. Our specific objectives here: 1. Solving integration using trapezoidal rule. 2. Area under a curve. Before we venture into this question, let me introduce you to the formula you need to be using. Area A equals 1/2h bracket y1 plus yn plus 2y2 plus 2y3 plus 2yn minus 1. Plus dot 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 into this formula. It depends on the number of ordinates given to you. Don't worry. When we solve, you will understand the formula very well. But before that, this y1 represents the first ordinate. The first ordinate. Yn represent the last ordinate. YH is simply x base n minus s1 divided by n, where n is the number of ordinates given to you. For instance, if you have 1, 2, 3, 4, and 5, how many ordinates are here? 1, 2, 3, 4, 5. To get your n, you will say minus 1. So our n here is what? 4. Can you see it? Then this will be taken care of from the integration symbol. Okay. This is the trapezoidal rule or trapezium rule. It depends on the one. They say using the trapezium rule with ordinates x equals what? 1, 2, 3, 1, 2, 3, 4, and 5. Calculate correct what? 2 decimal places. An approximate value for integral of 5, 1, 2s plus 8s raised to the power minus 2 ds. Some of us, you just rush because you know integration. You think it's the other one. Follow instruction using what? Trapezium rule. And of course, if you watch this, if you apply the other method, you can see it cannot work because it's complex. So that's why they are strict telling you the method to use. Just like when we are talking about the Simpson's rule. Okay, how do we do this? First of all, my interest is to get h. Where h is what? Like I said before, all over n. This is the upper case. This represents the lower case. That's or 1, 2, 3, 4, and 5. The starting one and the ending one. So where's the starting point? Sn, the last, which is 5. Then S1, the first value, 1. If you want to use that method to solve, no problem. Then n itself is just number of ordinates minus 1. If you have 7 ordinates, 7 minus 1, that is what? 6. So get it right, please. So h equals what? 5 minus 1, all over who? 4. Therefore, h equals 1. We have value of h now. But remember, how many ordinates we have? We have 5. Meaning, let me create formula for this. A equals 1 all over 2 into h bracket y1 plus 1, 2, 3, 4, 5. Y5. Can you see what I'm doing? That's why I introduced yn in that formula. Y plus yn plus 2y2 plus 2y3 dot 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 plus 2yn minus 1. Okay, so these are separate entities here. Let me just, they are separate. Plus who? 2y2, the second one, plus who? 2y3, the third one, plus 2y4. Finish. This is your formula for this question. You see, I'm generating it. I'm not struggling with it. I'm just taking my time to break it down. Now, what do? There must be a table for this. That's how it is being solved. There must be a table. Let us create our table. How do we create a table? You consider what you have in your integration. So what do you have in the integration? We are having this. If I am to create a table, I will have who? X. What are the values of my S? I will say the first value, 1. The second, 2, 3, 4, 5. Can you see? Now, come back to the integration. What do you have? This way, I have who? 2x, which is the first one. All right. What next? 8. All right. What next? X raised to the power minus 2, meaning 1 over s squared. I hope you are not confused. I also write. Finally, I want to get my y. Just like quadratic equation, you must write y equals whatever. So now, our y here is what? Root. That is square root of, let me call whatever that is here, who? K. Square root of k. So, at this point, let's continue. When s is 1, when x equals 1, 2x implies what? 2 times 1 equals 2. All right. When s is 2, 2 times 2, 4. When s is 3, 3 times 2, 6. The same thing for 4, 8. Then here is 10, okay? This guy is a constant. Remember your quadratic graph. 8 constant is constant all through with respect to the sign or the operator assigned to it. So this one simply means 1 over s squared, meaning 1 over 1 squared is who? 1, all right. 1 over 2 squared, meaning 1 over 4. 1 over 4, that is 0.25, okay? 0.25, I think we need to apply calculator here now. 1 all over 9, 0.111 dot 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 dot. It continues to go like this. Let's use calculator to apply these things. The next is 1 all over 4 squared, that is 1 all over 16. Calculator, 1 all over 16. Let's use the calculator to know the meaning of this, or you can still use our long division, no problem. But calculator will be faster for us. This is 16 into this. This is 0, okay? 0 times this is 0. I subtract, this is 1, 0. 16 is still bigger than 10. I'll put point. 16 into 10, that is 0, okay? All right, again. Subtract. So how many 16 are inside 100? We're going to think about it by trial and error. 16 times, let's say 8. This is 8. 4 carry, this is 8 carry 4. This is 8 plus 4. 1, 2, 8. You can see it's bigger than this. So 16 times 7. We give us this 56. 5 carry 5. This 7 plus this 1, 2. So it's still bigger. Okay? So it should be around. Now let's just punch calculator now to know the exact solution. 1 all over 16, 0.0625. 0.0625. 1 all over 9, 0.11111. That's why I put dot, 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 dot. Now let's cross-check this. 1 over 25 is going to give us 0.000 something over 4 point. Okay, 1 divided by 25, 0.04. Okay, 0.04. You can see. Now this one say root k. Recall that k is who? 2x plus s squared. That is plus 8x raised to the power minus 2. Or square root. That is taking the value of this. So now I want to interpret k. K simply means this plus this. See it? This plus this times this. Let us handle it very well. Otherwise, we'll be getting another solution. Recall that 8s minus raised to the power of this is the same thing as saying 8 all over s squared. Okay? Now, 2s from here, the first column row is the value of this is what? 2. So I am seeing 2s as who? 2. So I'm doing 2, then plus who? This gentleman, s into which is being interpreted as this. That is 8 all over s squared. Where is my s squared? That is, where is 1 over s squared? See my 1 over s squared. Now 8 over this is who? 8. This is what I have. So it's going to give us what? 10. Then square root of 10 is what? Square root of 10, perfect square is 1, 4, 9, 16, which is very close. This is 9. So meaning 3 point something. Okay, let's quickly use calculator to get the square root of 10. Square root of 10 equals 3.16. I will write 3.16. The same thing will happen here. 4 plus 8 all over 0.25. 8 over 0.25 plus 4, 36. Then square root of 36, I write 6. Very clear. Square root of 36 is 6, okay? Now, it is time for this. I have 8 all over 0.1111 plus 4. I think we missed something here for this. Okay, this is 4. We're done with this. Coming to display. Okay, this is 6. It's not 4 plus. We are done with 4 plus. That is 6 plus 8 all over 0.11111. It continues. It's a recurring decimal. 8 all over 0.1111 plus 6, 78. Square root of 78. 8.83. All right. 8.83. I can say 6.00 because of the other ones. This one is 2 decimal place. 3.16. 6.00. Come to this place. I will have what? 8 plus who? 8 all over 0.0625. This will give me 8 all over 0.0625. 128 plus 8. 136. Square root of 136. 11.66. 11.66. The next, I will have 10 plus 8 all over 0.04. That is 8 all over 0.04 plus 10, 2 tenths, square root of 210, 14.5, 14.49. 1. We are done with this. Now, whatever you're seeing, can you see this? It has been interpreted here. Now, go back to formula. Like we said before, we are going back to our formula. Recall that A equals 1 over 2 times H. Remember our H was who? 1. I said times 1, okay? The first one. Y1. Where is our Y1? 3.16. I write 3.16 plus the last person, 14.49, okay? Plus, if you watch 2 is uniform. I will now say plus 2 bracket 6.00 plus 8.83 plus 11.66, because I wouldn't want to waste our time here. Since 2 is common, I factored out 2 so that I can multiply when I sum everything up. 6 plus 8.83 plus 11.66. Don't call it 11.66, no. Multiply by 2, we'll have 52.98. This will give us 1 over 2, 3.16 plus 14.49 plus 52.98. I cannot talk to these ones. 3.16 plus 14.49, that's 17.65 plus 52.98 plus 52.98, it will give us 70.63. A equals 70.63 divided by 2. This is 35.315. Okay, that's the solution to that when we divide by 2. So that is the trapezoidal rule. We can solve another question from Examguide to make it the second one before we continue on the next topic. Okay, using the trapezoidal rule with 7 ordinates. Remember, the other one, we had 5 ordinates. Now they said 7 ordinates. 7 ordinates. Let's see what we have to find. Evaluate this correct to 2 decimal places. If I to do this to 2 decimal places, remember the difference between 2 decimal places and the significant figure. Immediately after the point, you start to count in decimal places. That's 1, 2, meaning 35.33. Assuming it is what? 2 decimal places. Let's look at this one here. We'll have on our Examguide seven ordinates. Let me wipe. We were told 7 ordinates, but it's like it's been omitted. Let's see how we can generate. The important thing is that, or the good news here is that you know the number of ordinates. This is 3, 0. The integration itself is ds all over s squared plus 1. Recall h equals what? Sn minus the first one all over n. Now they said 7 ordinates. 7 minus 1. Remember what I told you? That is 6. Now look at the integral. 3 minus 0. That is 3. It means h equals what? 3 minus 0 all over who? 6. To give us what? 3 all over 6. H now equals 1 all over 2. Unlike the first one we solved, our h was what? 1. The reason we had 5 ordinates and our range was what? 5 and 1. Lowercase was 1, uppercase was 5. But in this case, it's not like that. Now we have this. We are supposed to be given ordinates anyway to solve. Where they say 7 ordinates. If you have, let's say this is a line, you are starting S1, something like this, S1, S2, S3, S4. This is the way trapezoidal rule climbs, like this. As you're doing it, y, so you're also creating your y. Y3, y whatever. So S3, it climbs that way. Let's see if there is a way we can generate. If our general formula is A equals 1 all over 2 h into y1, remember the first ordinate plus the last, which is 7, plus 2y2 plus, I would now say 2y3 plus dot dot dot. I want to end, I say dot 2y7. I'm ending here. That y7 we will not use multiply by 2 dot 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 y7. That is the value of y7. That's why when we started, see, are you seeing any 2 here? No. The last one you are not multiplying by 2. The first one you are not multiplying by 2. But in between you are multiplying by 2. Now we have this. If we are to use, if the first person is 0, I want to generate. So you see how you can generate. H is what? 1 over 2. But just be rest assured that WAEC will give you the ordinate. But in case they refuse to give to you, I want to generate ordinate now. The first lowercase, the last 3, meaning 0, 0.5 is what? 0.5. Now, plus 0.5, 1. Plus 0.5, 1.5. Plus 0.5, 2.0. Plus 0.5, 2.5, and plus 0.5, 3.0. Can you see what is going on? Let's count. 1, 2, 3, 4, 5, 6, 7. Is it magic? There is no magic. It's application of what is deposited in you. So learn it. You also learn how to generate. So at this point, we have generated the ordinates, which was invisible in the question given to us. Now we have made it to come to physical realm, and let us handle it physically. We are no longer in the spiritual realm. Now, bringing it back to what we have, remember your table. Look at what I said about table. This S, okay? The first is who? 0. That's Y1. Second, 0.5. Third, 1. Next, 1.5. Next, 2.0. Next, 2.5. Next, 3.0. Do you know the reason why I have to stop at 3? Back to business. Uppercase is who? 3. Lowercase is who? 0. That's when you count 1, 2, 3, 4, 5, 6. How many ordinates? 7. You can see it's correct. Now let us proceed on what we are doing. So, coming back to this, remember this gentleman you are seeing here is simply mean this implies 1 all over S squared plus 1. Leave this guy, it's just the S. Okay, the S. So, I want to start. I have a constant 1. Constant will be what? 1, 1, 1, 1, all through. The next I have is who? S squared. S squared also is like that. And I have another constant, which is who? 1. I also produce it. 1, 1, 1, 1, 1, 1, 1. Okay. Then the buzz itself, which is the value of y, we'll have to create column for y. Let's call it y. Like we normally do, we can call the whole of this place any letter of your choice, but make them to know your mind, because examiners don't have time to read your mind, but you make them to understand what you have in mind. You are the one to read their mind, but they are not the one to read your mind. Therefore, be careful with whatever you are presenting. If you want to say, let this place, that's 1 over S squared plus this equals K, state it clearly, please. Otherwise, just write 1 all over S squared plus 1. Am I understood? Okay. Now, I want to do it with this. S squared, when S equals 0, S squared means what? 0. When S equals 0.5, S, okay, we use our calculator, but let's quickly handle the whole number 1. This is 4, and this is 9, okay? Applying our calculator, 0.5 times 0.5 should be able to give us 0.5 square, 0.25, 1.5 should give us 2 points square, 2.25. So 2.5 square, 6.25. All right, 6.25. Don't call it 6.25, because I hear some of you calling that kind of number. Now, I want to treat this one specially. Let's treat 1 all over S squared plus 1, meaning 1 all over S squared, 0, Abi, plus 1, meaning 1 over 1, 1. Settled? Look at what I did. Okay, trying to get the second, that's this one. Look at how the one came about. 1 all over S squared plus 1 implies what? 1. See the constant? 1, all right. All over S squared. When S was 0, what is S squared? 0, all right. Plus constant 1 to give us what? 1 over 1. 1 over 1 equals 1. I hope it's clear. Very clear. The second one, 1 all over S squared plus 1. This is when S is what? 0.5. When S is 0.5, our constant remains our constant. YS will give us what? 0.25. All right, 0.25. Then plus the constant, which is what? 1 all over 1.25. Let's check. Let's punch our calculator. this is 1 plus 0.25 plus 1, 1.25, 1 all over 1.25, 0.8. I will write 0.8. So I have to introduce decimal here because this has produced a decimal, one decimal place. So let's follow that order, okay? Though these ones, see, be careful too. The number of decimal places you have matters a lot. And one will say, are they going to kill us? They will subtract your mark. So you have to be very careful. Now the next one here is, I think we don't have a problem with this. Okay, just a little. 1 all over s squared plus 1 implies when s is what? 1, okay? Our 1 remains our 1, which is the constant. Our s square is who? 1 square, 1 plus 1 equals to 1 over 2, 0.5. You're right, 0.5. We'll come to this place. When s equals who? 1.5. We also deal with it. If s is 1.5, we'll have that 1 all over s squared plus 1 implies 1 all over s squared there is what? 2.25 plus 1 to give us 1 all over 3.25. Press or compute 1 all over 3.25, 0.30, 0.30, that's 0.3. We'll go over to this. When s equals, please learn how to manage your time at the same time. When s equals 2, this will give us 1 all over. What is s squared? 4. When s was 2, then plus 1. That's 1 all over 5, which will give us what? 0.2. You're right, 0.2. Then 6.25. We're going to have, that's 1 over 7.25. 1 divided by 7.25. 0.13. 0.13. Finally, 1 over 10 will give us 0.10. Okay? 1 over 10, 0.1. 0.1. So that is the table for what we are doing. Back to the question so that we can substitute when we finalize. The integration here is what? Integral of 1 all over s squared plus 1 ds. Formula here, a equals 1 all over 2 times who? H. Recall our h was who? 1 over 2. So into the first ordinate, 1 plus last ordinate, 0.1. I hope it's clear. I close it, plus 2 into all of them. Where are they? This plus this plus this plus this plus this, except this. That is 0.8 plus 0.5 plus 0.3 plus 0.2 plus 0.13. Close it. So what do we have now? A equals to 1 all over 4 into 1.1 plus 2 brackets. Let us take the summation of everything there. That is 0.8 plus 0.5 plus 0.3 plus 0.2 plus 0.13 equals 1.93. 1.93. Close it. Close all the brackets. This is what? 1 all over 4 into who? 1.1. This gentleman turns to 3.86 plus 1.1 3.86 plus 1.1 4.96 4.96 divided by 4. A equals 1.24. Instruction was given to us. What is the instruction? To 2 decimal places. Now let's do it. 1, 2. Can anything approximate? Nothing is at the back of 4. Therefore, our answer is what? 1.24. Let us go back to another question. Okay. Area under curve. Find the area under the curve y equals 3x squared. Then the ordinates x equals 2 and s equals 5. And the what? The x-axis. Okay. The interest here is just area. What comes to your mind when you hear the word area? You think about the unit of area. Just like when somebody talks about volume, you start to think about the unit of what? Volume. I'm talking about length, you start thinking about the unit of length. If I'm talking about velocity, you think about the unit of who? Velocity. Here, the case study is what? Area. It means it has something to do with, after solving, we say square meter or centimeter, assuming that length, the exact unit were given to us. But here, it's not given. So what you should just say square, maybe 4.2 square unit. Whatever is the unit is no longer your business. So find the area under the curve. You have y equals 3x squared and the ordinate. Look at the meaning of this. Whenever you hear area under curve, you are directly dealing with who? Integration, whereby the first ordinate is who? 2. The second, that is uppercase and lowercase. But y is self, okay? It's like this, 3x squared. Then I must introduce what I call the s. I don't want to go directly to this. First of all, I have to do something. When s equals 2, okay? Y equals to 3s squared. Y equals 3s squared implies what? 3 into 2 all squared. I will have 3 times who? 4, which is what? 12. Can you see what's going on? I am trying to create coordinates so that I can sketch a curve. Most of the times they will tell you, sketch a curve. But even if they just say find the area, that is, you must draw a curve. Now, and when s is what? When s equals 5, what do? You say y implies 3 into 5 squared. That is 3 times 25 equals to 75. So, if you are drawing your curve, you know how you draw it. But one thing I know, I have s equals 2 and s equals 5. For this, if I am to integrate here, I will have 3s cubed all over who? 3. Range 5, 2. Okay? What is uppercase minus lowercase? I say 5 raised to the power 3 minus who? 2 raised to the power 3. Any case here? No, this is 5 raised to the power 3. Should give us 125. 125 minus 8. Let's check first through our calculator. 5 power 3 equals 125 minus 8. So 117 square units. So this is the area under the curve. Now if I want to plot this, sketch this, you sketch it. You sketch it. But though they didn't say we should draw, but bear it in mind, you must learn how to sketch. Maybe let's look at another question. If such thing can come in, they say find the ordinates of the points at which the curve and the line intersect, then calculate the area enclosed by the curve between the line and the curve. Okay, two different things altogether. Given the curve y equals 4x squared and the line y equals 8x. Can you see wisdom? Now it is left for you, up for you to begin to think, how do I link this thing? There must be a navigation link for you to flow. Now let us see how we can link them. Okay. If they intersect, it means something of this nature. If I have a graph, if a curve is going this way and intersect a straight line, can you see? Something of this nature. This is what is in their mind. I am now reading the examiner's mind. This thing intersect. Meaning you have y-axis. You also have the axis of s. So if y equals 4s squared, also y equals 8s. This guy is y, this is y. It simply means that 8s equals 4s squared, okay? Whereby when I try to eliminate s, I will have 8 equals 4s. Then what is s? I'll have that. S will give me what? 2. Now, since I have two distinct for y, 4s squared and 8s, I also have two values. If there is no s existed ever, it means the value of s is what? 0. And the second point for the value of s is also the value we have here, meaning the coordinates. Look at the question. Find the coordinates of the points at which the curve and the line intercept. Am I communicating? So look at s-axis, the y-axis. We are able to produce the s-axis with 1 point, meaning the remaining 1 point for s-axis is not existing. When something is not existing, it simply means what? 0. Now is 0. I have the coordinate of s to be what? x1 equals 0 and x2 equals 2, okay? Now, when s equals 0, y will give us what? It is producing 0. And when s equals 2, y will produce who? Y equals 4 times this. That is 16. Let's also check this. When s equals 0, y will produce 8s. That is what now? 0. When s equals 2, y will produce 8s, which is what? 8 times 2, y equals 16. Can you see why people, they are very intelligent? Whatever they are giving you, they are very, very intelligent. The first solution and the second solution is still yielding the same solution. That's 16 against 0, 16 and 0. Meaning 1 point of the s values is what? 0. And 1 point for the y value is what? 0. Which point produces 0 against y? It was when s is what? 0. Meaning x1, I am trying to generate the coordinates question 1. x1, comma y1 equals what? 0, comma 0. Done. First solution. Second solution, s2, comma y2 equals 2, comma 16. Can you see how you present your solution? Now the next thing now, how do you draw? Sketch this curve so that it will make sense to what you are thinking about. Now I want to sketch the curve. let's assume, okay, when s is 0, remember center is who? 0. Y is also 0. If your y is, just take your ruler, just draw a straight line, okay? Now, I don't have a curve here. I want to remove it. Look at what happened now. Point of intersection, this is 0 point. So, when s is 0, y is 0. Most of us will know how to plot graph, but our problem is when it comes to this point, when s is 0, that y is 10, we'll come to 0. We'll be busy looking for the value of y. Y is already existing. This line you are seeing, they are all what? 0, based on s-axis. And this line you are seeing, they are all 0, based on y-axis. Assume that if y is 8, when s is 0, look at s0, then where is y 8? See, that's why you have to leave this point and go to this point to represent that 8. Now, see what I have. I'm done with 0, 0. I want to deal with 2, 16. If here I want to label it 2, 4, 6, I decided to stop here. This is minus s axis. I say minus 2, minus 2, minus 4. For this side, let me say 5, 10, 15, 20. Okay, here is my 20. When s is 2, y is what? 16. Meaning somewhere here. Can you see them? Point of intersection. I am moving a little bit here. See it? So, if I'm drawing my this thing, see, you have to be very intelligent. Meaning, this plus 16, also believe it is existing at the left-hand side, and this s that is 2 here is also existing here. So, you must try to get them so that you get the curve we are talking about. Can you see? It's passing now. It's not an imagination, but a reality. Therefore, this is the curve you have just finished sketching. That's why in most textbooks you will see. But at times you begin to wonder, how do they, this side, where is it coming from? At times you see them shading. Because of this, the point of intersection, that's the reason for the shading. So I'm done with first question. Calculate the area enclosed by between the line and the curve. Now I want to calculate the area enclosed by this curve. So I am producing this gentleman 0, 2. Recall, S has 0 ordinate and the 2. Look at it. It's the guy I'm dealing with. I don't have business with Y. So look at what will happen now. 0 and 2. Then that is 8x minus 4. I have double integration here. The first one minus the second integration. This 0 and 2, meaning 4s squared, okay? All what? ds. If I handle this, remember uppercase must still come here, but I think this question is interesting. Look at the lowercase, they are all 0, so you don't have to stress yourself again. Think about uppercase alone. Now let us integrate. If I integrate this gentleman, I will have 8s squared all over 2. Range is 2. I don't have business with lowercase again because it's going to give us 0. So I will say minus whatever I have here. This is 4s cubed all over 3. Then uppercase alone. This is not going to produce this. What now? This is 4s squared. The range 2, 0 minus. Let me just substitute. This will give me 4 into 2 all square. Then minus the lowercase, which is 0. I keep my answer. That is my solution here. For the first integration, I will have 16. I'm keeping it then minus the second integral value, which is 4 all over this. Let me come this way so you can see what I'm doing. That is 4 into 2 power 3 all over 3 minus 0. We don't have business here. This is 2 power 3 is 8 times 4. That is 32 divided by 3. 32 divided by 3. 10.6, and I say 10.66. Now area equals what? This should give us about 5.4 something. Like 16 minus 10.666, 5.33. So 5.33 square units. So the area bounded by this curve is what? 5.33 square units. Thank you for taking your time for this video. We are going to see an integration part 4, where we'll be talking about integration by parts. God bless you once again.